Alright, so if a function has a local extreme at a number c in an open interval, then one of two things has to be true. And we can look back at our examples from the first page in a minute. But one of these two things is going to be true if we have a local extreme, local max or local min. Either the derivative of f of c equals 0, or the derivative of f of c does not exist. Right, so two different things. Derivative is 0 or derivative does not exist. If we look back at our graphs here, we had local maximum here. Right? If we look at this, the slope, as we get closer and closer to that point, the slope eventually gets to 0 and then becomes negative. Right? It changes from a positive slope to a negative slope at that point. The derivative is 0. Here, slope is negative, then it's 0, then it's positive. Right? It's happening when the derivative is 0. Now, another way it could happen, and we don't have a graph here, but if we had straight lines, like an absolute value, the derivative does not exist there. So we could have something that looks kind of like a parabola at that point right there. The derivative equals 0. Right on this side we have a positive slope, and then it eventually gets smaller and smaller, approaches 0. And then over here we have a negative slope. Right, so it changes from positive to negative at this point, and that's 0. Or we could have, like I said, something like an absolute value, where left-hand derivative and right-hand derivative don't match, they're not the same, so right at this point, the derivative does not exist. Or something like a cusp. This is another scenario where the derivative does not exist at those points. But these are local maxes and mins. Alright, let's take a look at the next part. If a function f is continuous on a closed interval from a to b, so it has to be continuous, and its maximum or minimum value at a number c in that open interval, so if it has a max or a min at a specific point c, then the same thing is true. Derivative of f of c is 0, or the derivative of f of c does not exist. Right, so be a local max or local min, or an absolute max that's inside of a and b, like inside, not the endpoint, then the derivative has to be 0, or derivative does not exist. And last part, number c is the domain of a function f. A number c in the domain of a function f is a critical number, right, or a critical value. Key term that we'll use a lot this chapter, of f if either, times the term, derivative of f of c is 0, or the derivative of f of c does not exist. Alright, so those values where the derivative is 0, derivative does not exist, those are called critical values. I generally call it a critical value. You might see critical number from time to time as well. Alright, so as you can see, we've written this 3 times. It's important to know. Derivative 0, derivative does not exist. That's a local extrema. It's a critical number. And it could be an absolute max or min as long as it's not that endpoint. Alright, endpoint extrema. Remember that endpoints can be absolute maxes and mins, but not local maxes and mins. Alright, so endpoints can be absolute maxes and mins. But do not need to have a derivative of 0 or a derivative that does not exist. So the derivative does not have to equal 0, or the derivative does not have to exist. So, on those cases when you have an endpoint that's an absolute max or an absolute min, this does not have to be true. If it's in between the endpoints, it does have to be true, but endpoints do not have to have a derivative of 0 or a derivative does not exist.